afternoon, everyone. Ooh, that's loud. How nice. I'm kind of loud. You may want to turn that down just a little bit. Welcome to this afternoon session on Living on the Edge service. We're going to discuss building microservices to optimize consumption for devices using Spring Cloud OSS, Netflix OSS. My name is Mark Heckler. I am a principal technologist and developer advocate for Pivotal Software, Inc. Pivotal is a tiny little startup in Silicon Valley, makers of Spring Boot, Spring Framework, Redis, Greenplum, RabbitMQ, Cloud Foundry, huge contributor to Apache Tomcat, and a giant handful of other things. I speak English, obviously, y también yo hablo el español, pero no ancora parlo bene el italiano. So I'm going to working on it. Nowhere close. But thank you very much. You're very generous. But anyway, I blog semi-regularly. See, I can't even speak English now. At thehecklers.org, my personal domain. That's my email. And then I tweet very regularly at mkheck. I always tell people we only have an hour, which sounds like a lot of time, but it's never much time. So this is just kind of to kick things off. The best discussion really happens after the fact, so if you have any questions, comments, concerns, just want to brainstorm, my email's there. I actually live on Twitter, so that's probably the best way to get me, but by all means reach out. Happy to discuss things further. But I do need to really quickly get a selfie here, if you guys don't mind. So, and I'll cut myself out, because yeah. Wait, who let that guy in? That's my colleague, Jim Weaver, so. All right, I'm going to have to do this in twos here. There we go. All right. Hey, thanks, guys. Okay, we're done. No. All right. So, who am I? I'm an author of several blogs and blog posts. I'm a co-author of one book already, and another one's pending, and I contributed to others. I love to read. I love to write. I love to share. I've spoken around the world on various development-centered topics, and thank you again for inviting me here. Love Rome. Any place that lives this much for coffee, I am all in. So, but first and foremost, I'm a developer. I've worked for various consultancies and then Oracle, and now, of course, I hang my virtual hat at Pivotal. And I use what works, and I do my best to fill any gaps that I find, and I love open source. I think it's a model of the present and of the future. There are exceptions, but make no mistake, they are exceptions. I've survived years of working on monoliths and have struggled with the same issues you probably have, large, lumbering, brittle systems that are infrequently updated, inflexible systems with inflexible configurations. And finally, I'm always looking for a better way to deploy real software to production, software with actual business value, not undifferentiated heavy lifting, as Adrian Cockcroft, formerly of Netflix, likes to say. Advance. So let me ask this. Who here is a Java developer? Yeah, that's a good crowd. All right. Okay, well, yeah, the rest of you, what do you use anyway? I'm just kidding. Anyone here use Spring? Okay, good number. All right. Familiar with 12-factor apps, cloud-native concepts, things of that nature? Okay, really quickly, just to kind of broad brush overview. Spring Boot is an enabler. Spring Boot allows you to go from zero to app, as it says, in under 5 minutes. But what it really does is allow you to develop cloud-native applications very quickly and very powerfully using Spring components and Java. This is not your father's Java. So it's a very much annotation-driven, lean, very productive, opinionated approach to deploying applications that can run anywhere, including and especially in the cloud. Specifically, kind of what I'm going to be talking about today is Spring Cloud. Pivotal engineers and Netflix engineers have worked together for some time in partnership to develop some really good software. Netflix typically tailors it specifically to their use cases. Our engineers try to make it more broadly applicable so it has a lot of use and usability outside of Netflix's more narrow scope, obviously. But it works incredibly well for a lot of different things. Just to kind of cover the high points, and I'm going to cover as many of these as I can today, but there are more. and there is more to discuss. So again, afterward, let the discussion continue. Some of the key points, key components within Spring Cloud OSS or Netflix OSS. Typically, you want a centralized configuration. When you look at a microservices approach, a microservices architecture, you have many, many services that provide a capability, an end capability. So for each of those microservices, and even instances of each of those microservices, you can have a configuration that you'll need to manage somehow. This gets to be really difficult if you don't somehow centralize that configuration. That doesn't mean to create a bottleneck. A lot of times people hear centralized and they assume that now we're scoping things back and we've got one single point of failure. That's just not the case, and we'll kind of cover that here in a little bit as well. You also want some means of registering your services and discovering your services among your microservices. So you need a directory, and that's the functionality that Eureka provides. Spring Cloud OSS actually abstracts a bit, so it handles Eureka and HashiCorp Console, Apache Zookeeper, as well as some of the things for configuration. But we're going to look at Eureka today. That's kind of Netflix's advanced guard, so we'll cover that. We also want something that allows us to degrade gracefully, and that's what a circuit breaker does. We all have circuit breakers in our home, and if a bit of wiring goes bad or if we get an electrical surge, it may trip the breaker and cut power to a room or a part of your house or even your whole house. But that allows you to keep your house, so your house doesn't burn down. And anyone here a Netflix subscriber? Okay, pretty good number. Are you aware that when you pull up the Netflix interface in your web page, you see typically a band of offerings that says recommendations for you? Well, once in a while, if a service goes down, your recommendation service, you don't ever see just this big black box in the middle where everything just goes dark. You may see something like, here are popular selections in your area or your country, or here are things that people watching right now are interested in. So it degrades gracefully. It still provides value even when a backing service isn't online. You also want some kind of a load balancer. Client-side load balancer, again, so you don't have that single point of failure where something breaks and then you can't get to anything. You need intelligent routing, or you want intelligent routing so that you can access backing services without having to code things in directly. And of course, you want some method of security built in as well. So let's do this. That was the extent of my slides other than my wrap-up slides. So let's, whoops. Oh, I don't want to go into that yet. Let's get out of that. All right. So here we go. And let's bring this up. Every good story has a start and a starting point, and this is ours. Take a drink here. I'm getting dry. Not enough espresso. I only had 3 this morning. I told you I love coffee. Okay. Is anyone familiar with the Spring Initializer? Spring Boot, this is kind of the starting point. There are a lot of different ways you can get there from here. Oh, you know what? I forgot to load something here. I'm going to go ahead and pop that up now. And we'll come back to that. Okay. Spring Boot. Okay, have to start somewhere. What the Spring Initializer does, and you can access this via web page or curl or the Spring command line interface, but what this allows you to do is generate a shell project. So you tell it what dependencies that you want, what capabilities you want in your project, and it creates a level playing field for you. This is the compact version. Let's take a look at the full version. You can select your language, Java, Kotlin, Groovy. You can select your version, your packaging. Strongly recommend jar. You can go with a WAR if you're still deploying to an application server, but a jar allows you to deploy cloud native to any platform that runs the JVM, basically. But some of the capabilities you can choose right off the bat, just a quick run through. The advantage that this gives you is that it version levels everything. So if you want to pull in cloud connectors or MySQL or H2 or Zool or whatever, it brings that into a Maven POM or a Gradle build file, and it version levels it. So there's no chance that you'll ever have to go looking through things and say, oh, I brought in this dependency, it doesn't work, why doesn't it work? Oh, I have to drop back 2 versions, and everything works. So it takes care of a lot of those headaches for you, allowing you to focus on your business value. So again, you have a lot of choices just kind of out of the gate here. We're going to simplify this because we don't need to see all that, and it kind of makes your eyes bleed after a point. But we're going to start off with a few little setup pieces. So we're going to build out our microservices configuration as we go. And I have to try to keep an eye on time so I don't... somebody do this if I'm getting close to time. It's like, get him off there, okay? Okay, so we're going to first create a config service. And for our config service, we are going to pull in our dependencies for a config server. Very simple. We'll generate the project. And again, this creates our shell project. Let me put this somewhere here. And we'll do a new folder. And we'll save that. So we generate our shell project. It downloads it. Oh, that was interesting. And okay. And then we'll open it up in our IDE. I use IntelliJ. You can use NetBeans, Eclipse, Spring Tool Suite, which is based on Eclipse, whatever you choose to use. But this gets us started. Let's see, is that readable? Not very, is it? Yeah, let's see. How do I do this? Well, I may just have to zoom in here as we go. But the first thing we want to do is take a look. And as you can see, it generated our POM file for us that brings in our dependencies. In this case, it's not that much. We have one dependency. So the first thing that we want to do is go to our application.properties. And in our application.properties, we define certain things that our application will pull in and use as its foundation or configuration as it runs. So we're going to provide it a couple of different things. One, we're going to tell it what our get URI is. Excuse me. Yeah, I'm trying to remember how to do that. Preferences. Well. All right, where is it, guys? I've lost it again. Oh my gosh, okay, thank you. But it's not letting me change it here. Oh, I should have gone. Here, let me change it to default. That makes it a little bit better. Larger. Oh, that's kind of large. Perfect. You guys are killing me. Okay, well, wow, that's big. Okay, that's a little large, guys. Okay, stop messing with me here. Let's bring that back to maybe 24. Is that good? That's a good compromise. Okay. For our config server, we need something that provides the capability of versioning, of auditing, something that we have an interface to access and manipulate. And we use get. You can use SVN, but this is 2016, so we'll use get. But that provides us all the capabilities that we need, as well as our interface, command line, graphical, what have you. You can use GitHub, GitLab. You can point to a local Git repository, and that's what I will do, just because it's quick, simple, and I'm here. So I will point to one I have already in place, and that gets things rolling a little faster. And then we're also going to tell it what server port we're going to run this config server on. So we have our service properties set up. Let's go in and tell it, hit our main application class, and we're going to tell it first that we want to make this a config server. As you can see, it's very annotation driven, very short, sweet, and to the point. So you're not doing a lot of wordy, verbose Java. If you have been away from Java or been server-side Java for some time, you're probably not used to seeing anything quite this tight. But there it is. So let's take a look at this and make sure that everything comes up. That's always a plus. As you can see, it starts very quickly. So let's take a look. Now, the first thing I want to kind of point out is that for your config service, there is no web interface, so to speak. So when you point directly to it, you come up here. But what it does gain you is the ability to pull up your various configurations. Oh, I hate it when this happens. What did I miss, guys? What did I miss? Oh, yeah, it always helps when you don't have typos, too. Computers, so literal. All right, we'll give that a moment. Everything's running. So we refresh. Okay. The mistakes you make or see made today are purely mine. Okay. What are configs? Oh, yes, I can, actually. So there isn't really a lot to see here, but what this does show you is that for our config service, what it does is load, for any particular application, it will load generically the application properties and the properties that apply to that particular service. You also have the ability to distinguish based on platform, targeted platform. So as you can see here, application cloud properties would be loaded when you're deploying an application to the cloud. Now, as we go, what we'll see is things like this. We'll bring services online like an edge service. And this pulls up properties for that edge service, that application, as well as the general application.properties. So you can stack your property loads, if you will. So we have our config service in place, so let's go ahead and take the next step. Whoops, I was right where I wanted to be. At this point, let's go ahead and configure create our Eureka service. Typing always counts. And this will create our service registry that we use to register our various services and interact, look up, do our service lookups. Is anyone here familiar with the concept of a phone book? I know it's kind of an old thing. Now we just say, hey Siri, call Bob. But in the old days, you had this wonderful piece of book with many pages that you would look through and find your friend's phone number and then cross-reference it and call them based on the number that the book had. Really cool. 2 to 5 years ago, it was a thing. This is what a service registry is. It allows microservices to pull that directory and look up other services and find them. So we're going to create this. We want to first give it a web interface. We also want to tell it that it is a config client, so it goes out and pulls our config service for its configuration. And we want to tell it that, yes, it is a Eureka server. So we'll generate our shell project and save it down. Oh, I need to pull that back in. And we'll open it in our IDE. And we'll do things just a little bit differently here to start off with. First of all, what we're going to want to do is, the way Spring Boot projects work, Spring Boot applications work, is that they go through a bootstrapping process, and then they load the application's context. When it loads the application context, it looks for application properties. It reads in properties that are fed in via the command line, the Java command line. It pulls in environment variables and things of that nature. We want to kind of get out ahead of that so that we can pull our config service and get our configuration settings. So this is really, really difficult to do. We rename our application properties to bootstrap.properties, and that's it. So at this point, we'll obviously want to tell it where to go, how to find that. So we will tell it our cloud config Uri, which, if you recall, was, we're running it here locally, localhost 8888. And we'll want to provide our application name so it knows which properties to look up. And we'll call it Eureka service. Then we'll go to our main application class, and we'll tell it, voila, you're a Eureka server. And we'll run that. And we'll make sure that everything comes in properly. This is all fairly easy setup, but they're kind of critical pieces behind the scenes to get your services to be able to talk to each other. And as you see here, we are coming up on port 8761, which is fed to it by the config service. So that is connecting. What this allows us to do now is to hit our Eureka dashboard. This is our service registry dashboard. I'm going to have to bring that down just a little bit so we can see. Currently, there are no microservices that are registered with Eureka, but once we do have some, they will show up here. And this gives you kind of a dashboard of an overview of your services, your microservices, your instances of microservices, and all in one place. So, actually, right where I need to be. The next thing that we want to do, and I'll move this over, is create our backing service, because that's really where the fun starts. This is where we're going to create the service that provides us our important data that we're going to be using and accessing from our front-end devices. So we'll call this quote service. Anyone here a fan of movie quotes? Pithy historical quotes, funny quotes? Man, what do you guys do for fun? Okay, well, all right, we need to talk later. I like a good quote. I collect them like rocks or something. I don't know. I think it's really kind of nice when someone can turn a phrase. And I like to quote of the day. Anyone have a quote of the day app or an email or something they get? Oh, come on, you guys are killing me here. Get out a little. All right. Well, I'm going to create a very simple quote service that we're going to use to pull in and do this for the example, because I am a quote buff. So first we're going to want to provide a web interface. So we add that as a dependency. We're going to also want it to be a config client because, again, we're going to want to load our configuration from our config service. We're also going to want it to be a discovery client. And what that does is allow it to register with our Eureka service and pull our Eureka service to interact with other microservices as well. Now, a quote service isn't good for anything if it doesn't store quotes. So we're going to want to save these somehow. We will choose JPA for our database mechanism because, as a colleague of mine likes to say, we sometimes make poor life choices. But you can use anything, any JPA database. I'm going to use H2. It's a very peppy in-memory database. You can use MySQL, Postgres, Oracle. You can use NoSQL databases like Couchbase and Mongo. So you're really not very limited. Neo4j if you want to get into the graphing databases. But I'm going to use H2 for this. I also want to pull in REST repositories. And what that does is pull in the Spring data capability that allows you to tie any database that's listed in your class path to REST endpoints. Very nice, very capable, and very easy. So that's a huge plus. We like to focus on our business value, not on wiring things. Wiring things is fun occasionally, but you're never going to get a promotion out of wiring things the same way it's been done dozens of other times before. So we'll move past that. We're also going to pull in HATEOAS or HATEOS or however you want to pronounce it. It doesn't really matter. It's hypermedia. We're going to pull that in because that gives us the ability to navigate dynamically throughout our application. We're going to include the HAL browser, which gives us the capability of exercising our REST endpoints without having to develop our full application first. And then finally, we're going to pull in our security elements. And I will disable these initially until we get everything rolling, and then we'll go back and if we have time, re-enable them and just wire that all in. So we'll generate our project, our shell project. You know the drill. We extract it. And then we open it in our IDE, and I take a drink. Slowest part of the process is the IDE. Anyway, okay, and the first thing I'm going to do, because I often forget this to my great consternation, is to disable the security part initially, because otherwise it prompts me and yells at me initially. So, all right, so now we can get down to business. Again, the first thing we're going to do is rename our application properties to bootstrap.properties so that we can connect to our configuration servers and service and have it load what we need there. And again, we provide it with a couple of key elements, our cloud config Uri, and the application name, which in this case is quote service. And we want to do a couple of things here. First, we want to tell it that it is a Eureka. No, actually, I'm going to do a discovery client. This is a little more abstraction. This allows you to use other things other than Eureka without having to go back and change your code. So I just always kind of default to the enable discovery client. But for our purposes, you could also do enable Eureka client. Same in our example. Now, at this point, we have a fully working application, except we really don't have anything that it's doing. It has no quotes. It has no ability to store quotes or do anything with quotes. So it's kind of a useless application at this point. So let's add a couple of features to bulk that up. First, we're going to declare a JPA entity. Nothing fancy. We'll just make it a quote class because, again, two of us in the room like quotes. So we'll give it a few different fields, like an ID field and a quote text field, and maybe a source field. And we'll probably want to, give it a constructor or two. We'll need to do a default constructor for JPA. We'll also want to give it a constructor that we can actually use. Wow, I'm not used to the text being this big. I feel like I'm running out of screen. Just, you know what? Let's improve this slightly by making this slightly larger. Any little bit helps. And then we'll want to add some getters in there. And then we'll probably want to add in a toString just because it makes it nice to see. Yeah, why not? Now, we need to do one more thing to complete our JPA entity. We need to define what our ID field is. Easily done. And we'll need to tell the data store how to generate the value or address the value of our ID, which we'll just tell it, generate it. Excuse me. So that's it. We have, in less than a minute, we have an entity class defined that we can store our quotes in or do something with our quotes with. But we don't have any mechanism to store those at this point. So let's fix that really quickly. Very tough. There's a concept in Spring called a repository REST resource, and this is just an interface. We'll create one called quote repo because this is our quote repository, and we'll extend a concept called a CRUD repository. This is a repository that's built into Spring data that you define. You tell it what your type of class is, what your type of entity is you're going to be storing, and the ID type. And that's it. That gives you quite a bit of capability kind of baked in just for the get-go. So let's go ahead and run that. And as you can see here, we're coming in on port 8088. A little bit of trivia. Does anyone recognize that number? Oh, you guys are killing me. Okay. Oh, thank you. Thank you. The gentleman gets the prize. Okay, there is no prize, but anyway, thank you for playing. Okay, we're going to go to port 8088. And this is one thing I wanted to show you. Remember that when I mentioned the HAL browser? This lets you exercise your REST endpoints. There are a few things of note here. Remember that we defined a quote entity, a quote class. And we also told the REST repository resource to make that into something that we can interact with our database with. If you notice here, whoops, it created an endpoint for us. Oh, come on. Yeah, there we go. Yeah, well, okay. I need to zoom out first before I go over that far. There we go. It created an endpoint, which is an aggregate of those particular entities. And it did that for us. We can also go through, if you see over to the right, you see the HATOAS or HATOAS or however you want to pronounce it, the hypermedia links that allow us to navigate. You can go into here. Again, we don't have anything in here yet, so that's not really a great illustration, but let's go back and add something just so we can see how it comes in. The easy way to do that for us right now is to create a bean. And the @bean annotation in Spring allows you, in Spring Boot, allows you to define a method which returns a bean and adds it to our bean container. We're going to define a command line runner. And before I do that, I'm going to auto-wire in our quote repository. And what this allows, the auto-wire does is it injects that bean into this particular class. So Actually, I'll just leave it there. I could have done an injection, but we'll go with it with this. I'm going to cheat just a little bit because otherwise it takes me too long to type, and I want to get on with this. But what we're going to do here is a little bit of Java 8 magic. Command line runner is an interface. It has a default method. So we're going to define that default method and what it returns, and we're going to, as a command line, on the command line, run a certain bit of functionality when we load the application. That's kind of the extremely high-level overview. I'm going to pull in these quotes because I like these quotes, and you'll probably see why. We're going to pull in some quotes, define those, save them in our repository, and then just to verify that everything happened, we're going to iterate through each one of those. And what this allows us to do when we start up our application is to start with a quote repository that actually has some quotes in it. And as you can see from the startup down here, I need to learn to come over here. Yeah. So we see that we have some quotes already populating in our database. So now if we go back to our web interface, our HAL browser, we can see basically the same things, but when we go in and get our quotes, you can see over here that we actually have quotes. So we can go into each quote, we get our standard JSON response. You can also do non-get, so you can do a put, an update, you can do a delete. It allows you to do a lot of testing right here, kind of live, and exercise those endpoints before you create an application. So that's a nice little extra included, no extra charge. So now, so far what we have is the ability to retrieve all quotes or a particular quote by ID. And actually, with our repository REST resource, let's try saying that 3 times fast, it defines certain default, that's probably not the best way to put that. It defines certain methods that allow you to find based on the ID or the source or the text. But what we want to do is somehow return a non-particular quote, a random quote, because a quote of the day application that keeps giving you the same quote every day is not worth a whole lot. So what we're going to do at this point is create a REST controller, and we'll call it class random quote, if I can type right. And what we're going to do is auto-wire in a REST template. Oh, no, actually, no. I'm getting ahead of myself again here. What I want to do is do a request mapping, and we will call this random. And we will return a quote. And what we're going to want to do, actually I was on target here. We're going to inject our quote repo again. Now, our quote repository, as I said, just has the methods that are defined by default by Spring Data. What we're going to want to do is provide it a unique method. And we can define that by defining a query that we provide ourselves. Something along the lines of select queue from quote queue order by rand. This will return us, let's see, this will return us our, what I'm going to do is return a list of quotes in a random order. If I can type right, that's the key. And just providing this much information allows Spring Data REST to go ahead and create that method for us. At this point, what we can do is do our quote repo, get random quotes, and we will choose the first one. Nothing fancy, but this will get us what we need for our demonstration. Oh, yeah, okay. Again, so literal. Okay, we're doing fine. Okay, so we see that our quote's loaded. Let's go back over to here. And actually, I'll just skip right up here. And now what we should be able to do is pull back a random quote. So we can refresh, and we get various quote. So just in recap so far, what we have is a config service that allows us to pull in our configuration and manage our configuration from a central source. We have our discovery service registry and discovery mechanism that allows us to register microservices and interact between microservices. And then now we have a backing service that we can access and do something with. Excuse me, time for another drink. Now we need to create an edge service that we're going to use to access that. So any 3 guesses where we go to do that to start? Spring Initializer, right. So we'll create an edge service. We're going to give it a web interface as well. We also, again, want to be able to access our config service. And we want to give it Eureka discovery capabilities. At this point, though, we want to provide it some front-end capabilities like Hystrix, a circuit breaker, so we can degrade gracefully. If we cannot reach our backing service, we want to be able to degrade in such a way that we still provide some value to our front-end users, but we don't just blue screen on them, so to speak. We also want to pull in our client-side load balancing, and we want to provide our intelligent routing. Finally, we want to bring in our OAuth capabilities and our security, which, again, I will disable initially, and then we'll go back and re-enable it. Save it down. Open up the project. And we'll pull that in. OK. So again, we're going to want to change our application properties to bootstrap.properties. And we'll provide it, again, the key information, Sping, the Config Uri, and application name. And we're going to want to tell it as well that in this case, we're not going to tell it that it's a discovery client. We're going to tell it it's a Zool proxy. That brings in the discovery client capabilities for free. What this allows us to do is use intelligent routing to get to our backend services or backend service or services, as well as public APIs. So this gives us the capability of doing that kind of as is. I'll show you this really quickly, and then we'll come back and I'll show you a little bit more. And as you can see here, we're going to go with port 8086. And oh, I forgot to disable security. Always happens. Simply done. Go to the POM. I am going to just move one of these just to make it a little easier on me because it goes alphabetically, and what I want to be able to do is disable them both at the same time. And we'll enable auto import, expand that slightly, and then we'll restart that. And that should get us what we need. Okay. And as you can see, now you're probably wondering, why is this passing through? And this is a point where we bring over, wow, that is small. Okay, we're going to expand that. The first line of this, well, okay, the first line of this is really where the meat is. Because Zool allows you to define routes without doing anything other than configuring this route in Zool. If you notice the quote service, Zool does a lookup in your discovery, your registry, Eureka registry. And it looks up that service name. So when it sees that service name, it takes any path that you provide that starts with QS and routes that to that service. As you may recall, on our backing service, we have something called quotes. So we see quotes. We also had something, an endpoint for a random, and that's exactly what happens. So maybe that's enough. Maybe that's what's referred to as a micro proxy. Maybe that's enough for you. Maybe that gets you the functionality you want for your edge service. Chances are you'll want to somehow massage that, though, and do something with the data that you're returning. So let's take a look at that next. And wow, that's big. I feel like I'm looking at a... You guys have like the giant pencils and crayons for kindergartners when they're, that's kind of what I feel like I'm looking at it here. It's like, wow, it's so big. Okay, so a couple ways to do this. I'm just going to create a class here. We'll call it quote. But I'm going to strip things out. I really don't need the ID on this, so I'm just going to create a quote class that has the text. And we'll say, we'll do the source as well. Why not? And we need a no parameter constructor for our JSON conversion. Always something, right? And we'll go ahead and do our getters. Okay, so a couple things we can do here, because to manipulate this, what we'll want to do is create a REST controller. And we'll call it class new quote. I can't even type. Okay. And we're going to auto wire in a REST template. What this allows us to do is reach out to other APIs, internal or external, and do something with this particular class that we have, or with this particular entity that we have. So we're going to do a request mapping, and we'll call this Quotorama. Why not, right? And we will return, our quote, get random quote, REST template, get for object. And a couple things of interest here. We're going to tell it just to look it up by the service. And we're going to tell it to return, keep wanting to shortcut that. Ha, remembered. Okay. And of note is that we're still using our Eureka service to look up our particular endpoint in this case. Neat thing about this is this works for local endpoints. It also works for public API endpoints. This is just one example I'll show you, and I'll take this back to the configuration settings to kind of tie it all together. So again, we still have our Zool routing, which is automatic. We also have the ability, since we defined this as an endpoint, to go directly there. But if you look at what we have here in our routes, I've also defined a route which anything that starts with quote in our path then forwards it to a local endpoint. That also works for, again, public APIs. So you have several ways you can get there. All roads lead to Rome, right? So in this case, you can manipulate that. So we lost our ID. We stripped our ID off of that. Very simple example, but it shows you that whatever you're getting in, you can manipulate and do something with and then carry on with. We're getting really close on time. I want to be able to definitely show you a couple more things, one of which is the Hystrix capability, which is our circuit breaker capability. Netflix, again, put this in because you want to be able to show your customers something and not just a big dark screen in the middle. So what happens if you have an issue returning this? You need to have some way of generating something that's of value. So we're going to define this as our Hystrix command, and we're going to provide it with a fallback method. At this point, we don't have a fallback method defined, so we're going to define one. Get random, well, we'll do a get fallback quote. How's that? Well, this is better than nothing. All right. So Hystrix also, in the Netflix OSS suite, there is a Hystrix dashboard, which allows you to keep track and watch visually as things fail. Because when an endpoint goes offline, when a microservice goes online, a backing service, what happens is that circuit breaker is tripped. And you want to be able to visually observe that happening. Hystrix will go out and over time, after it's been the circuit breaker has been open for a while, it'll go out and occasionally try to send a request to that dead service. And if it connects successfully, it'll go ahead and start ramping back up the communication, the traffic. If it isn't, then it goes ahead and continues to fail, do the fallback method. But over time, of course, as that comes back online, then all traffic is restored to it. I won't show you the dashboard right now because, again, that takes a little more time and it's generating yet another microservice to pull in. But this is all that's required. You define your method, you define your fallback method, and then you run it. So that what should happen, if I've done my demo correctly, is that once we go here, we see that, of course, everything is fine. But let's go kill our defenseless service. Okay, so now it's dead. Our quote service is dead. So when we go here and refresh, well, it's better than nothing. So, okay, you guys are a tough audience. Wow. Thank you. I was going to say, I killed my quote service for you. Oh, but I'll bring it back. I'll bring it back. Okay. I think we have enough time to go ahead and SSL enable things, which is kind of neat because it allows me to show you the config service and how we go ahead and update that as well. So let's see here. What we want to do is, let's go ahead, because for our edge service, we're going to want to SSL enable that. And that's, again, really difficult to do. We're going to change the port, and we're going to provide a key store. So now that we've, yeah, you're laughing. Yeah, it is really pretty much that simple. But what we have here, yeah. What we have here is we've updated our configuration file, but our configuration service is still using the same old config. And one thing about it, if your config service goes offline, your application has buffered all of that config, so it's not a big deal. All of your services don't fall on the floor. Same thing with your Eureka service, because when you have your client load balancing, it will go out and pull down its destinations so that if your Eureka service goes offline, everything continues to run. It's very survivable. One thing I didn't point out on one of the earlier slides is it talked about brittle architecture. When you have a monolith, one application that does everything, it's either up or it's down. So your chances of it being up are pretty good, and when it's down, everything just stops, right? When you have microservices, let's say you have 10 or 50 or 500 microservices that work together to provide a certain piece of functionality, one cohesive piece of functionality at the end. What are the odds that any one piece of that pie is offline? Because for each microservice, let's say you have 500 of those, and let's say for each of those you have 10 instances, what are the odds that one of those is going to be offline? Pretty high, right? Well, Netflix makes plans for that. If you've ever heard of Chaos Monkey or Chaos Kong, the Simian army, they know that things will go offline. They know that services will fail. So when a microservice fails, another one is spun up and takes its place. And you have mechanisms in place to accommodate that. So overall, you have a very reliable, available system. But that doesn't mean that every one single piece is always online. You can't count on that. You shouldn't count on that. So anyway, I digress. But we've updated our configuration service, config properties. So if we go out and look at our get status, we can see that we have a modified properties file. We're going to go ahead and commit that. And that's all it takes for the config service to go ahead and get updated configuration information. We'll go out and take a quick look at that. And as you can see here, we now have our key store information that's coming through. So our config service is up to date. So what I need to do at this point is go back to my edge service. There we go. That's my quote service. Go into my edge service. I will restore security capabilities. This just brings in the dependencies in the POM file, so when it goes ahead and spins it up, it is smart enough, Spring Boot is smart enough when it sees certain libraries on your class path to enable certain capabilities. Again, you don't have to do that by simply making them visible on your class path. Spring Boot does that for you. It's a very, very powerful concept. So at this point, when we go back to our edge service, oh sure, what did I miss? And it's just passing it directly through. What did I miss, guys? Help me out. Oh, quote service. Oops. This stuff works. I just sometimes get going too fast. Does that mean I need more espresso or less espresso? I still am having trouble with that part. I think it means more. We'll go with more. Okay. And as you can see here, we're still going to our old HTTP port, so nothing comes up, which that is as it should be. But now when we go here, we're secured through and coming through on HTTPS. So we have a secure encrypted connection. I think that's kind of pretty much do it, because there's no way I can get through the OAuth part at this point. So let me go back to this and unmirror and pull this up. Helpful links, spring.io guides, Spring Boot, Spring Cloud. These are excellent jumping off points. I have all my repos out there, and what I don't have out there, I will have out there over the next few days. But by all means, if you want to snap a shot, that's great. This is kind of the starting point. It gives you a lot of capabilities, again, for very low impact and lets you concentrate on the business value proposition. So let me sum up with this. Microservices can be hard, but they don't need to be. If you build a robust infrastructure and make it secure, you can accomplish an awful lot. You can split out your monoliths. You can have a more robust and reliable architecture, even though you add some complexity. You also add extensive capability. And Netflix does it. You can too. So thanks for attending, everyone. And any questions at this point? Yes? How do you test? Is that what you're saying? Well, I mean, you use your standard. Oh, excellent.
So what about automated testing in microservices? If you test a single microservices, all the single microservices, or all the possible interactions, and if you provide some library frameworks.
Well, I mean, you do all the same basic things that you do in normal development work. You do your unit testing as well as your integration testing. A lot of different options that you have out there when you're dealing with the cloud. I mean, I'm from Pivotal. I guess I mentioned that earlier, but when you deploy to Cloud Foundry, you have certain options in Cloud Foundry as well. But your testing suites that you typically already use are fully supported. JUnit. I'm drawing a blank now, but also. Your monitoring gives you a lot of capabilities as well, because when you're live with microservices, you're passing a lot of data back and forth, you're exercising endpoints. You need to be able to do that live as well. There's an old saying, I can't remember who said it, but sufficiently advanced monitoring is indistinguishable from testing. So when you have live monitoring going on and you see things break, you can actually close that loop as well. If you do like blue-green testing, so you take things live in a smaller environment, you can see things that you won't catch in your standard testing environment. And ultimately with microservices, you do have to embrace more of that back end. That's probably the wrong way to put that. More of the testing when it's live than you would ordinarily with a monolith where you can extensively test it before you bring it online as a whole. So did that kind of answer things?
Yeah, thanks.
Okay. All right, well, yes. Yeah, I mean, you typically don't want that because anytime you tie together two microservices in one data store, you have a single point of failure, you have integration at the database level. Typically, you want to have some form of eventual consistency and your microservices that have specific to that microservice data stores. It's a different way of architecting it, and it makes people a little queasy at first, you know, when you're used to having that consistency at the database layer, but allows you to you know, scale your microservices much better by doing it that way. And with a colleague of mine always says, get used to eventual consistency, just embrace it, because that's ultimately where it has to be. Banks are one of the most risk-averse entities on the planet, and banks have had to embrace this eventual consistency, because if you're withdrawing money from an ATM on one side of Rome, and maybe your wife is withdrawing money on the other side, you know, it's not going to lock both transactions until it makes sure that everything is there. And that can cause problems, but from a practical perspective, you have to, in a distributed system, embrace that you're going to have some of the eventual consistency issues and solutions to address them. So, yes, sir.
What about you're building microservices application by creating a lot of microservices?
Yeah.
Thank you. I said, what about the performance of your application? Mm-hmm. The whole application, I mean, you're building a microservice architecture by creating a lot of services. Mm-hmm. And the service laying on the edge of the application are calling other services in the background of your whole architecture. Mm-hmm. But in this scenario, you have a lot of decoupled code, okay, but if one service have to call other 5 underlying microservices, so you have the work of the translation between I don't know your API entity into the JSON code, and then only in the end you could return the result to your end user, and that seems a little less performant than a monolith application.
Well, and a lot of that depends on how you look at it, because if you're typically you'll have several microservices, or even if you have one large monolith, if you're requesting something, I'm trying to think of a great example, and I'm just coming up empty here, but if you're requesting let's say you have a travel site, and your web interface has full capabilities for listing all flights and all hotel rooms and everything, that's quite a lot. But on a mobile device, you would want that shrunk down quite a bit. You wouldn't want to show all of that, certainly not all in one page. So you'd want a much reduced data set to come back. So by not pushing all of that information across the pipe, you're using an edge service to massage that data and to reduce that data and present it in a way that provides just what you need. So your performance, you're right, you're adding another, wow, that's a lot of feedback. You're adding quite a bit of, you're adding another service in there as your edge service, but you're also reducing your communication. You also, by doing that, reduce the issues or remove the issues with cross-origin resource sharing. So you get the capability of aggregating that information behind the firewall, if you will, and returning just the information that's needed in a way that doesn't set off any alarm bells, that you don't have to push permissions out across multiple microservices or cloud instances or things of that nature. And remember, behind the scenes, when I show you you're hitting a service, you're typically hitting several services, and each of those services has several instances. So those are all load balanced. So you're trying to, at any given point, your edge service is trying to find the least busy resource and pull that back. So typically what you see is your performance actually improves or can improve dramatically from that. So, okay, I think we're getting the hook. Thank you very much. Really appreciate it.